Good morning, everyone. Uh, sorry, hi everyone. This is G. Shanmuka, and today's topic is code optimization. Okay. Here, first of all, we need to know what is code. Code means it's a programming program which is a set of some instructions which we give to a system to be executed so that the system could work according to our requirement. And here, the requirement is not enough with the what means with what we wanted to do by the system, but the time it takes to execute what we give the instruction that we give is also matters. So for this, we need to give a better code or a better program which can be executed with a good time complexity and space complexity. Here, the concept of time complexity and space complexity comes with optimization of code. Means the optimization of the code means the working of the code should be much faster and much efficient so that we could get the appropriate output with less time and less time complexity and space complexity. The main idea of the code optimization is this, and we'll be looking into the topic uh, optimization. In computing, optimization is the process of modifying a system to make some aspect of it to work more efficiently or use fewer resources. Example, a computer program may be optimized so that it executes more rapidly or is capable of operating with less memory storage or other resources or draw less power. The system may be a single computer program or collection of computers or even an entire network even an entire network such as the internet. Now, optimization is a program transformation technique which tries to improve the code that consume less resources, means CPU or memory, and deliver high speed. 16. In optimization, high-level general programming constructs are replaced by very efficient low-level programming codes, usually done at the end of the development stage since it reduces readability and adds code that is used to improve the performance. Code optimizing features executes faster, code size get reduced, and efficient memory usage, yielding better performance and reduces the time and space complexity. And code optimization are classified into two categories. Machine independent optimizations improve target code without taking properties of target machine into consideration. And machine dependent optimization, which improves target code by checking properties of target machine. Criteria for optimization. An optimization must preserve the meaning of a program, cannot change the output produced for any input, cannot introduce an error. Optimization should, on average, speed up programs. Optimization should itself be fast and should not delay the overall compiling process. Optimization can occur at several levels. Design level means at the highest level, the design may be optimized to make best use of the available resources. The implementation of this design will benefit from the use of suitable efficient algorithms, and the implementation of these algorithms will benefit from writing good quality code. Compile level use of an optimizing of compiler tends to ensure that the executable program is optimized at least as much as the compiler can predict. Improvements can be made at various phases. Source code. Algorithms transformation can produce spectacular spectacular improvements. Intermediate code compiler can improve loops, procedures, calls, and address calculations. Typically, only optimizing compilers include this phase and target code. Compilers can use registers efficient in this code, target code. And main techniques of optimization. These are main techniques. Yeah, the major techniques which we use for code optimization or implementing the code optimization is code movement, dead code elimination, compile time evaluation, common submission elimination, strength reduction. Okay. Now, there are primarily three types of optimizations. Local optimization, which is used to apply a basic block in isolation. Global optimization, apply across basic blocks. And optimization, apply on loops. Another significant optimization can be peephole optimization. It can be applied across boundaries. Now, code of optimization performed within a basic block. This is simplest form of optimizations. No need to analyze the whole procedure body. Just analyze the blocks of the procedure. The local optimization techniques includes constant folding, constant propagation, algebraic simplification, operator strength reduction, rate code elimination. Local code optimization is here constant folding. As the name suggests, this technique involves folding the constraints by evaluating the expressions that involves the operands having constant values at the compile rate. Circumference of circle means example. Circumference of circle is 22 by 7 into diameter. Replace 22 by 7 with 3.14, which can be easier. Means we can skip the step of division of 22 and 7, which can be more efficient in compared to previous step. This could be a type of code optimization and constant propagation. In this technique, if some variable has been assigned some constant value, then it replaces the variable with its constant value in the further program whenever it has been used during compilation, provided that its value does not get after in between. Example, PL is equal to means pi is equal to 3.14, radius is equal to 10, area of circle is equal to pi into radius into radius. So substitutes constants value during the compile time and saves the solution. So algebraic simplification. Use of algebraic properties to simplify expressions. Some expressions can be simplified by replacing them with equivalent expressions that is more efficient. You can see the example over here. Strength reduction. As the name suggests, this technique involves reducing the strength of the expressions by replacing the expensive and costly operators with the simple and cheaper ones. Dead code elimination. Those code are eliminated which are either never executed or not reachable, or even if they get executed, they are to never be utilized. Common subject special elimination eliminates the redundant expressions and avoids repetition again and again. Global code optimization. Optimization across basic blocks within the procedure function could be restricted to be smaller scope. Example, a loop data flow analysis is done to perform optimization across basic blocks. Each basic block is a node in the flow graph of program. These optimizations can be extended into the entire control flow graph. Most of compiler implement global optimizations with very well-known theory and practical cases. Optimization technique that operates on the one or few instructions at a time. Performs machine dependent improvements. Keeps in a single or sequence of 2 to 3 instructions peep hole. Replaces it by most efficient alternative instructions. Peep hole is small moving window that system target systems. Okay. Redundant characteristics of peep hole optimizations. Redundant instructions, eliminations, flow of control, optimizations, elimination of multiple jumps, elimination of unreachable board, algebraic simplifications, reducing operation and using of machine readiness. Loop optimization. Here, loop optimization plays an important role in the improvement of the performance of source code by reducing overheads associated with executing loops. Loop optimization can be done by removing loop invariant induction variables. Okay. Thank you, and this is the end of the discussion. And hope you have got a clarity of how what optimization actually works. You need to even summarize the whole topic what we have discussed here. Please maybe consider just consider what is an optimization. Optimization in the direct general meaning itself is to simplify a complex thing. So here also, the reason behind the simplifying the complex factor is to save the what we say, save the working of the brain means what we want to get can be get simpler is called optimizing. Means optimize we will say optimize the solution. Yeah. Okay. When we talk about code optimization, here we have given an example. Let me see. Yeah, here means cannot find, but still, when we here when we talk about the circumference of a circle, here we can use two formulas. There are 22/7 into diameter, and another option is 3.14 into diameter. Here in these two cases, in first case, the system has to compute the two aspects. First thing is it has to divide 22/7, and then it has to multiply the result with the diameter. This is here it consists of two steps. When we consider the second step, in this step, the system will directly multiplies the value 3.14 with the diameter. It will be a step forward when we compare it with the previous method. So thus the code optimization can be improved with the improves the space complexity and time complexity and efficiency of the workability of and this is the end of the discussion, guys. Thank you.